Once you have the basic hockey stick shape of the exponential function, you can kind of see how it starts to increase as your x's get bigger. You can use the idea of translations and reflections to sketch a graph of this and know what its horizontal domain and range are going to be. So for example, if I add 3 outside of the function, adding or subtracting inside or outside the function rather is going to be a shift up or down. So if we're adding outside, that's going to mean it's going to shift up 3 units in this case. Which means this entire picture, including the horizontal asymptote, is going to go up, still retaining that same hockey stick shape. So if I draw this up, and I know where the horizontal asymptote was and where it should be, I can go up 3 units, sketch in the horizontal asymptote, and then know directly 1 unit above the horizontal asymptote, I have a point on my graph. And then from there it goes up 2, and I can make a rough sketch of this knowing that it's an increasing function, so from left to right this thing is going to go uphill, and there's the picture. So my new horizontal asymptote has the equation y equals, you got to put the y equals in there, 3. The domain is the same, that didn't change, it's still all reals, and you can either do the big R or negative infinity to infinity. And then the range, well, that's changed because you shifted everything up 3 units. It can't go below the number 3, and in fact it can't touch the number 3, y equals 3, so we put a parenthesis on the 3, and then all of your y values are up to infinity. So without really drawing a picture in, I can take a look at this function. The minus 5 outside of the function means we're going to shift down. So if we subtract outside, it's going to be a shift down 5 units. And then you can imagine where the new horizontal asymptote should be. If you've shifted everything down 5 units from this original picture, the horizontal asymptote drops down to y equals negative 5. The domain doesn't change. There's no radical or denominator with a variable in it, so the domain's all real numbers. And then the range, again, if you can imagine the picture of just dropping this down to negative 5, it'll get close to negative 5 and then blow up to infinity on the y values. Okay, so that was outside the function. What if you make the move inside the function? So if I have y equals 2 to the, let's go, x plus 3 inside the exponential, inside the exponent. Well, if it's inside, so we're going to add inside, that means we're going to shift either left or right, and if you're adding, it's going to go left 3. Remember, it goes kind of in the opposite direction of what you would maybe naturally think it should go, but it's going to go to the left 3. So this entire picture is just going to shift over 3 units to the left and then plot it and draw it in. Horizontal asymptote didn't move. You didn't go up or down. So our new horizontal asymptote is still at y equals 0. Domain didn't change either. We didn't put a denominator or square root in the problem. So that's still all reals. And then the range, again, your horizontal asymptote kind of is a blocker, so you're not going to go past 0, and it's still going to open or increase left to right. So if I do a y equals 2, and then put x minus 5 up in the exponent. Again, it's inside the exponent, so that means it's going to shift right 5 units. And then again, horizontal asymptote didn't change, still y equals 0. Domain didn't change, so that's still all the reals. And then the range also didn't change. It still can't go any lower than 0, goes up to infinity.